Welcome to the Selenium training day 3. Fine. I'll create a new Java project called day 3 out here. Okay. And in this project, I am going to add all the Selenium jar files. Right click. Java build path. Alright, hold on. Selenium 2.25 and add these two jar files, and don't forget to add the jar files under library. Okay. Now, that day in the last class, I told you that there is a separate driver class. Fine. There is a separate driver class for every driver, and you need to create the object of each driver class in order to work with it. Fine. For example, there was Firefox driver class. To work with Firefox, you need to create the object of Firefox driver. For Chrome driver, you need to create Chrome driver class. Fine. So similarly, uh, every browser has a driver. There's a driver for iPhone, there's a driver for Android. Everything is there. Okay. And we studied about the concept of object-oriented programming as well, through which we learned everything. Fine. So I'll again come back to the concept of object-oriented programming, right? And I will make the same class car which I had made that day, and in that, sorry, I made a different class, but I'm making a car class, class called car, and I'll keep the class name as, I'll keep a variable called name. Fine. Now what is this? This is a non-static variable, right? Now when I create a new class, right, I suppose I write over here test car with the main function. Okay. In this class, if I create the objects of the car class, I can create like this. I can write like this: car C equals to new car. Okay. Say C1. So I can give various objects C1, C2, C3, C4, and I can give their names. I can write C1 dot name is car A, C2 dot name is car B, right? And this is exactly what we do in Selenium as well, right? After creating the Firefox driver, Chrome driver, IDE driver, objects, we call their methods and properties, right? C4 dot name is D. Fine. Now in my car class, if I make a non-static function, if I write over here, hold on, yeah. If I write over here public void start, and in this function I write system.out.println starting car plus the name of the car. So again, this is a non-static function, right? So in the memory we have got 4 objects. All the 4 objects will have the name and the start function, and every object has got an object reference associated with it, right? C1, C2, C3, C4, okay, and every object has got name and start name variable and start function inside it, right? So now when I write over here c1 dot start, so this will print car starting and the name of the car, that is, hold on, I'm running this into the Java application. See, car starting A, because when I call the start function of C1, it prints the name of C1, right? Similarly, for other objects as well, C2, C3, C4, we can do, right? And it will print car starting car A, B, C, D like this. Fine. So this is what we had studied earlier as well. Okay, that is non-static stuff is part of the object. Now what about static? If I declare a global variable called, suppose, int wheels, right? Now we know that every car has got 4 wheels, right? Every car has got 4 wheels. Fine. So it makes no sense to initialize the wheels for every car separately. C1 dot wheels equals to 4, C2 dot wheels equals to 4, like this. It doesn't make sense, right? So what we do is that we make the wheels static. Now, by making the wheels static, what happens in the memory is that uh, the wheels variable will never be the part of an object. It will reside at a common location out here, and all the objects, they can access it from here. Okay, so static is something which is same for everybody, right? It is not the part of the object. Non-static is something which is part of the object. Okay, to access the static variables, it's not necessary to access it through the object. You can directly write over here, static is not the part of the object. You can directly access it. You can write the name of the class. The name of the class car dot wheels equals to 4. So static stuff can be accessed directly with the name of the class. I cannot write car dot name equals to BMW. I cannot write like this. Because name is a non-static property. It is inside the object. You need to create the object of the car class to access it. But wheels out here is static. Fine. Okay. Hold on. Can you have a static? Yes, you can have it. This is the main function. Sorry, no, you cannot have it. Inside a function, if you declare a variable static int x equals to 100, it doesn't make sense. Okay, static variables are can only be declared at the global level. Okay, inside a function, nothing is static. Okay, inside a function, if I am declaring a variable int I equals to 100, this is neither a non-static variable nor a static variable. It's just a simple variable. It cannot be termed as static or non-static. Static or non-static variables are the ones which are declared globally. Okay, if you have I'm sorry, if you have a variable at inside the function, fine, then it is neither static nor non-static. It's a simple variable whose life is just inside this particular function, right? So Okay, so this was about static. Static is something which can be accessed with the name of the class dot the function of the variable. If I have a function out here called as public static say move, then this move function will be common for all the objects. You can write inside it car moving. Okay, so now if you have to call it, you just have to write car dot move. So static stuff can be called directly with the help of the class dot. You won't need to create objects. So if you run this, you see that car moving. Now we use static stuff as well. For example, I will again create a new Java project. So sorry, not a Java project. A new class called as Chrome. Fine. And that day we had seen that we need to download the Chrome driver.exe in order to work with Chrome. Right? If I go to hold on. If I go to Google and I type download Selenium, right? I go to the downloads page of Selenium, and in this I had told you, right? Actually I need to download that Chrome driver.exe because I am at a different PC. Just a minute. Chrome driver for Windows, yeah. So you download the zip file. Right, and just a minute. This is the exe file, right? And right, so I'll in my C drive I'll make a folder called as Chrome. In this I'll keep the exe file Chrome driver.exe. Right, now that day I had told you, you have to write the line to work with Chrome. You need to set the system property. You need to write system dot set property WebDriver dot Chrome dot driver. Okay, in the property you need to give the path of the exe, that is C drive Chrome and Chrome driver dot exe. Right, now just a minute. Now what is system over here? System is an inbuilt class in Java. Okay, and it's got a static function. You see that static function is there called set property. That's why I'm able to call this function directly with the name of the class. I'm not creating the object of the system class, right? But to work with Chrome driver, I need to create the object of Chrome driver, because in Chrome driver most of the stuff is non-static. So I have to write Chrome driver equals to new Chrome driver. I think you got the logic, right? Fine. System is a class and set property is a function inside it, right? Similarly, Chrome driver is a class. If I write Chrome driver dot there is no static function except a simple thing called class which is never used inside Chrome drivers. Everything is static. Everything is non-static. If I write over here driver dot, you get all the non-static elements inside the Chrome driver class, right? So that's how we will be studying, like we'll be moving on with Selenium, right? So just try to understand two things. Firstly, static is something which is the property of the class, and non-static is something which is property of the object. Okay, to access non-static stuff present in a class, you need to create the object of the class. To access the static stuff, you can access it directly, like system.setProperty I have written over here. Okay, if I run this, then in console, okay, spelling mistakes, Chrome driver, I will see that a blank Chrome has opened up, right? Okay, now similarly, if I have to work with Firefox, I need to create the object of Firefox driver, right? I need to write over here Firefox driver dr equals to new Firefox driver. But the question which arises out here is that I'm sorry. The question which arises out here, will there be different sets of functions in Chrome driver and Firefox driver? And suppose there is an Internet Explorer driver, or suppose there is iPhone driver, Android driver, Safari driver, right? So will there be different sets of functions? If I have to click on a link in Safari driver and Chrome driver, will the commands be different? Because every driver over here, this is the Chrome driver, will have some set of functions, and similarly the Firefox driver will also have some set of functions associated with it, right? Now the answer to this question lies in the concept of interfaces in Java. So I'll move back to Java now, and I will talk about interfaces, right? What an interface is, what it represents, how it works, and when should you use it, right? I'll create a new class, and hold on, I will create a new, instead of class I'll select interface, fine. And suppose I name the interface as, hold on, you'll get to know that what interface does. Suppose the interface name is laptop. Okay, now interface, as I always tell people in every class, it's just like a la carte menu. When you visit a restaurant to have your food, fine, what is there in front of you? You have the a la carte menu in front of you, right, in which the name of every dish is written and the price is written, and a little bit of description is also there, that what that dish will consist of, or how is the dish, fine. But how that dish will be prepared, it's not your job, or it's not visible to you, right? So interface is just like that a la carte menu. It will tell you what the application is supposed to do, fine. For example, what are the features of laptop? I can write over here public void boot, right? Public void say shutdown, say public void recharge, right? So just a minute, right? So these are the some of the features of laptop. If you notice that I have not given the method bodies out here. I have just declared the methods that this is my laptop interface, fine, and these are the methods which are there in the interface. Okay, I will not be, I am not concerned that how these methods are implemented, but in the interface I just keep the methods that fine, these are the methods I am going to have, and this will be the structure of my laptop. Okay, so interface is like a rule book which tells you what all will be there inside your laptop. Fine. Now I will create a new class, a new Java class. Just a minute, guys. Alright, that was my daughter. I'm sorry. So I will create a new class called as HP underscore laptop. Fine. And in this class, right, now this class belongs to HP. HP as a company manufactures laptops, right? So you'll write over here implements laptop. Laptop is the interface which we created, which describes what a laptop should be doing. Fine, it should boot, it should shut down, and it should recharge. HP decides that it should implement the laptop interface. That means HP decided to make laptops, right? So you write implements laptop out here. Now when you write implements laptop, it has to this class HP laptop will have to implement all the functions from the laptop interface. You see there is an error over here. If you move your mouse over the error, you can get add unimplemented methods as a resolution to this error. When you click on this, all the three functions boot, shutdown and recharge come in this class with the bodies. So if a class is implementing an interface, okay, if a class is implementing an interface, it is supposed to implement all the methods from the interface. Okay, if I decide that fine, I want to skip the recharge method, then I will again get an error. If a class is implementing an interface, then it's mandatory for that class to implement all the functions, right? And if you look at it carefully, there's a sign called @override in front of every function, right? There's a sign called @override which is there ahead of every function. This override sign, even if I delete it, it really doesn't make a difference. Okay, you can delete it. But what does this sign tell you? This technically this is known as an annotation in Java. This is known as an annotation technically, and this tells a layman, like suppose I make the code and you come and read the code, you read that fine, this class is implementing laptop, then this @override sign means that this function is actually coming from the HP laptop. This function is actually coming from the laptop interface. So looking at this sign, a layman layman means a person who has not made the code, he can actually understand that this function is coming from the laptop interface. Okay, so interface is something which will tell you what the application is supposed to do, right? And a class which implements the interface should be implementing all the functions. For example, in the boot function I'll write system.out.println HP booting. In shutdown I'll write HP shutting down. In recharge I write HP recharging. Now the question arises, what was the need of implementing the interface? Why can't I just write 3 functions in HP laptop and my work is over? That's it. Okay. This is the question which arises. Why am I implementing the interface? Can't I simply write 3 functions and that's it? Well, look at the bigger picture. Suppose I make a new class and I name the class as Acer. Now Acer is also manufacturing laptops. So again I will write over here Acer implements laptop. So when Acer is supposed to implement laptop, it will implement all the 3 functions, and inside the boot function you will write Acer booting, then Acer shutdown and Acer recharge. Okay, fine. Technically both the classes HP laptop and Acer are different. They both implement the laptop interface, okay, and they both have the same set of functions, but the functions, they have a different definition inside every class. Now suppose I make a class called as test laptops with the main function. In this class I can make the object of anything. If I write over here HP laptop, HP equals to new HP laptop, right, and I create the object of Acer as well, Acer AC equals to new Acer. The functions in both the objects should be same. If I write HP dot boot and Acer dot boot, boot is the same function. It is coming from the laptop interface. It is same in both the laptops. If I run this, I'll see the message HP booting and Acer booting. Fine, but where is the difference? The difference lies that the implementation of the boot is different for HP and different for Acer. As a layman, suppose now, is there some noise coming? I'm not sure what was that noise. Anyways, suppose a layman comes up. A layman comes, he looks at the interface laptop and he knows that HP laptop and Acer laptop both are implementing the laptop interface. Then automatically he will know that both the classes have these functions, right? Okay. If you are not able to understand, then please feel free to ask me any question. You can ask a question through chat, you can talk it over on WebEx, okay? Don't just sit over there, right? Feel free to ask me a question, okay? Now, in Selenium, okay, in Selenium, as I told you, everything is pre-built. You need to understand the architecture of Selenium. You need to understand what is there in the Java docs out here. Okay. Now in Java docs, on the left hand side, if you scroll, you will see the classes, all the classes which are inbuilt. Fine. All the stuff which is written in italics is an interface. For example, mouse is an interface. It is written in italics. Event firing mouse and HTML unit mouse, these two are the classes which are implementing the mouse interface in Selenium. Everything is inbuilt. You need to understand the documentation. And these are the methods provided by the mouse interface. So that means that these methods are also available with event firing mouse and HTML unit mouse. Okay. So I'm just giving you an example out here that if you know interface, you can understand what it's doing.